All right, guys. So example 2, we have a solution of sodium hydroxide. Okay. It's prepared by dissolving 1.0 grams of solute in 5 liters of water. Determine hydronium concentration, hydroxide concentration, pH, and pOH. All right, so let's just think about this. Okay, sodium hydroxide. If I write out the chemical formula for that, okay, I have NaOH, which we know is an ionic compound, which is a solid. And that makes sense based on the question because it says I take 1.06 grams of solute and put it in water. Now, when I take an ionic compound and I put it in water, hopefully this is drilled into your heads, it dissociates. And it dissociates into sodium ions and hydroxide ions in this case. I care about the concentration of hydroxide, but before I can do that, I need to figure out the concentration of NaOH. And because they both have a coefficient of 1, they will be the same. All right. So let's think about what I have for NaOH. I have the mass. The mass is 1.06 grams. Do I know the molar mass? Yeah. The molar mass is 22.99 for sodium, plus 16 for water, plus 1.01 for hydrogen. I'm going to get 40.00 whatever grams per mole. When I have mass and molar mass, what can I calculate? You can calculate the moles, mass over molar mass. You guys can see that. So my moles are 0.0265 moles. Okay, now I want concentration and I have moles. Okay, to find concentration, I got to do C equals N over V. 0.0265. Again, this should be review for you guys. 5.00 liters. Concentration is 5.3 times 10 to the negative 3 moles per liter. Now, we know that I can ride the molar coaster because I have a single arrow, which means it's 100%. And so the concentration of hydroxide is going to be the same, 1-to-1 relationship. Okay. So all I'm going to do up here, guys, because that's part of the question, it's asking us to do that. I'm just going to write it up here. 5.3 times 10 to the negative 3 moles per liter. Okay. And then I'm going to save some room. So I'm going to erase this because you guys should have seen it by now. Okay. All right. So hopefully you guys were able to track that. So I got my concentration of hydroxide because I was able to get the concentration of NaOH and then ride the molar coaster. Well, I can do this a couple different ways, but if I have the concentration of OH minus, let's just go out and find the pOH with that easy calculation, negative log OH minus. Okay? Let's just do that right away. Okay. You're going to get 2.2757 ... There are, how many sig digs were in the question? I believe there were 3 sig digs. So this should actually be 30. My apologies, because it's 3 sig digs. And that means that if there's 3 sig digs in concentration, 3 decimals in pOH, 2.276. Okay. So I'm just going to keep track of that. Actually, I have it there. Okay. Well, right away, let's just go out and find, if we have the pOH, we can really easily find the pH because pOH plus pH is 14. I'm just writing 3 decimals here because there's 3 decimals there. Keeps it easy. So pH is 14 minus the pOH, 14 minus 2.276 pH is 11.724. Easy. Okay. Well, if the pOH is low and the pH is high, this is definitely a base, right? pH is above 7. We also understand that because this is a metal hydroxide, which is a strong base, and it produces OH minus. Now, the last thing that we have to do in this question is we have to determine what the concentration of hydronium is. We can do this in two ways. We can use the KW formula like we did in the last example, or we can do 10 to the negative pH, okay? Now, if I'm gonna do 10 to the negative pH, I wanna use the, I kinda wanna use an unrounded number, okay? So I'm gonna just carry a few more decimals. So if I didn't round this number, okay? If I didn't round that number, minus log, I got 2.275. Okay, that was my pOH. If I do 14 minus that, I get this. That's my real pH, unrounded. I want to use this number just to make things a little more accurate, because you never know how rounding is going to go when you start raising things to the power of 10 and logging it. So just use the whole number. Okay, 11.7242 dot, dot, dot. All right, remember that negative sign right there. And remember brackets in your calculator. So I'm going to do 10 to the power of bracket negative answer, like that. And I'm going to get 1.88679 dot, dot, dot times 10 to the negative 12 moles per liter. Okay, when we do wrap sig digs on that, we got 3 sig digs, 1.89 times 10 to the negative 12 moles per liter. Okay. Again, you can find that using KW formula, that's fine. But again, you guys can start to see the relationship between everything. In this lesson, okay, we're only looking at strong acids and strong bases, which is what we did in grade 11. The next lesson and the lesson after that, we're going to start looking at, well, how can I calculate pH and pOH? If I don't have a strong acid or a strong base, what if it's weak? And if it's weak, I can't use the molar coaster. So what am I going to have to do? That's next week.